Okay, welcome to session 6. I think yesterday we discussed a few problems. I have tried the last problem which I was given as assignment. Did you get the correct answer? No doubt in the last question. Okay, okay, thank you. So you can note down the next problem. You can note down the next problem. Two cover plates 10 mm and 18 mm thick are connected by a double cover butt joint. So this is double cover butt joint using 6 mm cover plates as shown in figure. Find the strength and efficiency of the joint. Find the strength and efficiency of the joint given M20 bolts of grade 4.6 and Fe 415 plates are used. So this is double cover butt joint. So double cover butt joint. It is required to calculate strength and efficiency. You need to calculate strength and efficiency for this double cover butt joint. Even you can copy the diagram. You can copy the diagram also. So this is double cover butt joint. So this is your first plate 18 mm thick, and your second plate is this. This is your second plate, which is 10 mm thick. This gap is filled by packing plate. Okay, so double cover. You have cover on both sides. So double cover butt joint, and thickness of this cover plate is 6 mm. Okay, so total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bolts. 12 bolts of grade M20. M20 and 4.6. This distance is 40. Next, this will be 60. Again, this is 60. Again, this is 40. Okay. Then the total width of the plate. What is the total width? You calculate the total width of the plate. So it is 60 plus 60 plus 40 plus 40. So total width of the plate is 200 millimeter. Okay. Here this distance is 40. This is 60. And this is 40. 40, 60, 40. Is it clear? I have taken the diagram. If it is over, we will proceed for the solution part. Say yes or no. Okay. Okay. So next I will proceed for the solution. Okay. See here. So for M20 bolts, so next is solution. For M20 bolts, what is the diameter? So nominal diameter 20 mm. Clearance 2 mm. So your whole diameter, so nominal diameter plus clearance, so it is 20 plus 2, so your D naught is 22 mm, or it is sometimes denoted as DH. Okay, so grade of bolt 4.6. So for 4.6 grade, what is FUB? 400 Newton per millimeter square. And what is FYB? 240 Newton per millimeter square. Okay, correct. From the diagram, you tell me the pitch and edge distances. From the diagram, above diagram, you tell me the pitch and end distance. Pitch is 60 mm. End distance? End distance is 40 millimeter. Okay. So you can refer your diagram. Okay. Next is sum of next you find the sum of thicknesses of cover plates. Okay, see here, it is double cover butt joint. At the top also you have cover plate, and at the bottom also you have a cover plate. What is the thickness of top cover plate? Cover plate it is 6 mm top cover plate. What is bottom cover plate? 6 mm. So sum of thicknesses of cover plate, it is 12 millimeter. 6 plus 6, it is top cover plate, and again 6, this 6 is bottom cover plate, so 12 mm. Next is you find the least thickness of plate. Least thickness of plate. So if you observe your diagram, one plate is 18 mm thick and another plate is 10 mm. So least thickness is 10 mm. Okay. Next, you find the n value. This is capital letter N. So N means number of bolts on the one side of the joint. How many bolts are there? Number of bolts on one side of the joint. See, if you observe this diagram, on one side you have how many bolts? 1, 2, 3, 4, 5, 6. So here N is 6 numbers. Number of bolts on one side of the joint. Okay. So now tell me whether this butt joint is subjected to single shear or double shear. Double shear. So you have two failure planes. So one is at this. This is your failure plane 1 and this is your plane 2, shear plane 1 and this is your shear plane 2. Okay. So next you can write like this. Butt joint is subjected to double shear. Butt joint is subjected to double shear. Okay. So you can assume NN as 1, NS as 1. So total 2 shear planes. Total 2 shear planes, which means one plane is intercepting the shank and other plane is intercepting the thread. So I can assume like this: NN1, NS1. Okay. Now you can calculate ASB and ANB. ASB complete full area pi d square by 4. ANB 0.78 times into pi d square divided by 4. So your nominal diameter of the bolt is 20 millimeters. You find ASB and ANB. What is ASB? Yes, correct. ANB it is 245 millimeter square. ASB it is 314, almost it is 314.15 mm square. Either you can assume it as 315 mm square. Okay. So with all these datas, now you are able to find the shear strength. So first step is nominal shear strength of 1 bolt. So first we will calculate the nominal shear strength of 1 bolt, then we can find the design shear strength of 1 bolt. If you multiply it by 6 bolts, you will get the design shear strength of joint. Okay, so nominal shear strength, you know the formula, VNSB equals FUB divided by square root of 3 NN multiplied by ANB plus NS multiplied by ANS multiplied by 3 correction factor beta LJ multiplied by beta LG multiplied by beta PK, 3 correction factors. Okay, first we will find beta LJ. So first we will find beta LJ. What is beta LJ? What is this beta LJ? So this is the correction factor for long joints. Correction factor for long joints. Okay, so first you find the distance LJ. You find the distance LJ. What is LJ? First you find the distance. How it is 60? So LJ is 60 millimeter. Huh? So I think you remember the clause 10.3.3.1. Okay. Next you find the 15 into D. So 15 multiplied by volt nominal die is 20. 15 into 20, 300 millimeter. Now you have to compare this LJ and 15 times D. So you can comment like this: LJ is less than 15 times D, because your LJ is 60 millimeter, whereas your 15 times D is 300 mm. You can comment like this. If this is the case, you can assume beta LJ as 1. If this condition is satisfied, then you can directly take beta LJ as 1. Okay. Next correction factor is beta LG. Next correction factor is beta LG. What is it? So this is the correction factor for large grip length. So this is the correction factor for large grip length. Okay. So next you find the distance LG. Next you find the distance LG. What is LG? It is grip length. LG is grip length. How to calculate this grip length? So see here. So I think in the last class I showed a diagram. So how you find the distance LG? So this total thickness is LG. Now you find the distance LG. This plate is 18. This cover plate, top cover plate is 6. Bottom cover plate is 6. What is LG? So 18 plus 6 plus 6. So in your case, LG is 30. LG is 30 mm. Correct. So your distance LG is 30 millimeter. Okay. So again you remember the clause, same 10.3.3.2. So you find the distance 5D. So 5 into diameter of bolt is 20. So which is 100 mm. Next is you compare your LG and 5D. So your LG is 30 mm and your 5D is 100 mm. So here LG is less than 5D, which means 300 is less 30 is less than 100 mm. So if this was the case, you can assume correction factor beta LG as 1. You can assume correction factor beta LG as 1. Okay. Next correction factor beta PK. So this is the correction factor for packing plates. Okay. So in your diagram, thickness of thickness. What is the thickness of packing plate? What is the thickness of packing plate? See here, this is your packing plate. This is your packing plate. What is the shaded area? Shaded area is your packing plate. See here, this plate is 18, and this plate is 10 mm. And then what is the thickness of packing plate? 18 or 8? 8 millimeter. So thickness of packing plate is 8 millimeter. So thickness of packing plate, it is 8 millimeter. Okay. So for this correction factor, you need to refer 10.3.3.3 clause 10.3.3.3. Let me open the code. See here 10.3.3 packing plates. 10.3.3.3 packing plates. See here the design shear capacity of bolts carrying shear through a packing plate in excess of 6 mm shall be decreased by a factor beta pk given by. So this is the formula. Here what is the thickness of packing plate? 8 mm. It is greater than 6 mm. It is greater than 6 mm. So your correction factor should be this much. So beta pk equals 1 minus 0.0125 thickness of packing plate, TPK. So here TPK is thickness of the thicker packing in millimeter. If your packing plate was 4 mm, you can directly could have taken beta pk as 1 because it not exceeds 6 mm. So here in this problem packing plate is 8 mm thick. It is greater than more than 6 mm. So you need to use correction factor. See here in the same page you have all the three correction factors. See here this is for long joints 10.3.3.1 long joints. 10.3.3.2 this is for large grip length. So 15D from there I used. Okay, for large grip length it is 5 times here, 5 times the diameter, 5D. So this is 10.3.3.3 for packing plates. Okay, so here you need to use the correction factor beta pk equals 1 minus 0.0125 into tpk. So 1 minus 0.0125 thickness of packing plate, it is 8 mm. Now you solve this and you find the beta pk point. So it is 0.9. Beta pk is 0.9. Okay, so now you can calculate VNSB equals FUB divided by, I will directly substitute. What is FUB? 400 divided by root 3 multiplied by NN, NN1, ANB, ANB, 245 plus NS, NS1, ANS. So it is 315. First correction factor 1, second correction factor 1, third correction factor 0.9. You simplify this and you find VNSB 116.39 kilonewton. So this is nominal shear strength of one bolt. So this is nominal shear strength of 1 bolt. Okay. Next you find the, in the next step you find the design shear strength of 1 bolt. Next you find design shear strength of 1 bolt. You know the formula VDSB equals VNSB divided by gamma MB. So your VNSB is 116.39 kilonewton divided by gamma MB is 1.25. You find VDSB 93.11 kilonewton. So this is for 1 bolt. 1 bolt. Okay. So for 6 bolts, in case of butt joint, we have to consider bolts which are present only on one side of the joint. So 6 bolts. So what is the design shear strength of 6 bolts? So next you find design shear strength of 6 bolts. It is 6 multiplied by 93.11. What is the answer? Okay, 58.66 kilonewton, or it is nearly equal to 560 kilonewton. You can round off to 560 kilonewton. This is design shear strength of 6 bolts. So once the shear is over, next you calculate the bearing strength. So next is bearing. Again it is nominal. First you find the nominal strength of bolts in bearing, and for which you need to find KB first. And first formula is E divided by 3d0. Second is P divided by 3d0 minus 0.25. Third one is FUB divided by FU. Fourth one is 1.0. You tell me this first. E divided by 3d0. 0.60. How you calculated? Your edge distance is 40 divided by 3 multiplied by 22. Okay. Next this one, second one. Zero 0.65. How it is? Your pitch is 60. 3 into 22 minus 0.25. Next, FUB divided by FU. For bolt it is 400. For plate it is 410. How much it is? 0.9. Sorry. Yes, you change this to FE 410. FE 410. Or you can use 415 also. What is the difference? while using 400 divided by 410, I have the value 0.97. 400 divided by 415, 0.96. It is not a much difference. Your last value is 1. This is last value is 1. Among 4 values, you have to choose least value. So least value is, so your KB is 0.60. Your KB is 0.60. Next, same formula, VNPB equals 2.5 KB DTFU. 2.5, your KB is 0.60, D is diameter of the bolt 20, T is the thickness of the plate. What is 10 mm? You have to consider least. FU is 410. Either you can use 415 also. It is 123 kilonewton VNPB. So this is nominal bearing strength of one bolt. Nominal bearing strength of one bolt. Now you find the design strength VDPB. It is VNPB divided by gamma MB. So your VNPB is 123 kilonewton divided by gamma MB is 1.25. So your VDPB is, okay, almost it is 99 kilonewton. So this is for one bolt. This is for one bolt. Okay. What is the design strength of 6 bolts in bearing? So you multiply this by 6 into 99. 590. Okay, it is almost 595 kilonewton. So this is design strength of 6 bolts in bearing. So this value is the design strength of 6 bolts in bearing. Okay. So next is you need to calculate strength of plate, which means same procedure. Design strength due to rupture of critical section, which means TDN. What is the formula for TDN? 0.9 into AN FU divided by gamma ML. You first find the value AN. AN, you know the formula, B minus N into DH multiplied by T. Now, what is B here? Width of the plate? 200 minus N value. What is N here? 3. Why? Number of bolts which are present on critical section. So it is 3. DH 22. Thickness of the plate, which means thinner plate, 10 mm. You find the value AN. So it is 1340 mm square. Okay. Next you solve for TDN. So 0.9 multiplied by 1340 multiplied by 410 or 415. It will not differ much. So divided by gamma ml 1.25. So you find the value TDN. So it is 396 kilonewton. So this is strength of plate. This is strength of plate. Is it correct? 396. Okay, next. So next step is strength of joint. Strength of joint. It is very simple. You have the shear strength, you have bearing, you have strength of plate, you have strength of plate. What is your design shear strength for 6 boards? For 6 boards, 560 kilonewton. For bearing, 595 kilonewton. Your strength of plate, 396 kilonewton. So out of these three values, you have to choose least. So 396. So your strength of joint is, design strength of joint is 396 kilonewton. Next is your efficiency. So efficiency, you know the formula. Strength of joint divided by strength of solid plate multiplied by 100. First, for the solid plate, you find the area. For the plate, you find the area. Width into thickness. Width is 200, thickness is least 10. Wherever you have the thickness, you have to use the least one, because it will give the critical results. 200 into 10. So 2000 mm square. This is the area of solid plate. Then you know the formula. TDG equals AG Fy divided by gamma MO. Your AG is 2000 multiplied by Fy. Fy is 250 divided by gamma MO is 1.10. You find the TDG 450. Okay, I will round off this to 455 kilonewton. Next, it is very simple. So efficiency eta equals your strength of the joint is, I think it is 396 kilonewton divided by strength of solid plate 455 kilonewton multiplied by 100. So your efficiency is 87%. So efficiency of the joint is 87%. You have calculated the strength of the joint. This is your first. It is asked to calculate strength of the joint and efficiency. Strength of the joint is 396, whereas efficiency is 87%. Okay. Shall we take next problem? Hmm. So this is your next example. Two plates 10 mm thick are joined by 16 mm diameter bolts in a triple staggered lap joint. It is lap joint. Find the efficiency of the joint. Use 4.6 grade bolts. Use 4.6 grade bolts. So two plates 10 mm thick. So this plate is 10 mm, and this is also 10 mm thick. Diameter of the bolts 16 mm. Diameter of the bolts 16 mm. The type of arrangement is triple staggered lap joint. This is very important. Triple staggered lap joint. Find the efficiency of the joint. It is required to calculate the efficiency. Use 4.6 grade bolts. Use 4.6 grade bolts. So you take down the diagram also. This is the diagram. Triple staggered arrangement means you have four columns. One, two, three. Three columns in a staggered manner. See here, you have first bolt like this, next bolts like this, next you have like this, next like this, next. This is staggered. This is staggered arrangement. So from this edge to this distance is 25 first. Next, from this bolt center to this row 20. Next, from this row to this bolt row 20. Next, replica. Next, it is same replica. From year to year 20. From year to year 20. Next year 20. 25 replica. From this plate edge to first bolt center for 25. From this bolt center to here this distance is 40. Next replica 40. This is 25. 25. Once you taken the diagram, once you take the diagram, just remind me. Is it Tor? Have you taken the diagram? Okay. Next, next is solution part. Hmm. So they have not specified anything about plates. So you assume Fe410 plates. You assume Fe410 plates. You just note down the important points. It is very difficult for me to explain each and every step. You note down the important steps and results. Assume Fe410 plates. Diameter of the bolts, they have specified it as 16 mm. So your D is 16 mm. You have two plates, thickness of first plate 10 mm, thickness of second plate 10 mm. So these are thicknesses of plates. Okay. The type of joint is lap joint and it is triple staggered. Already you know the difference between what is the lap joint, what is triple staggered. So lap joint means two plates overlap each other. So your arrangement is like this. It is lap joint. Triple means three rows of bolts are provided across the width of the joint. So you have three rows. Staggered. The bolts are in one row or positioned between the bolts of the next row instead of being in a straight line. So I told you it in the beginning. So first bolt you have like this first row, next you have like this next bolt. So this arrangement we call it as staggered arrangement. Okay. Next, from the figure, what are all the data you may get? Pitch. From your diagram, what is the pitch distance? 40 mm. From bolt center to bolt center. I think they have mentioned it clearly. It is 40 mm. What is end distance? 25. What is gauge distance? 20 mm. Next, you calculate the width of the plate. Next, you calculate the width of the plate. Next, you calculate the width of the plate. It is very simple. You need width of the plate. You have to add all the dimensions. I am audible now. Hello, am I audible? Okay. So for width of the plate, you have to add all the dimensions. So 25 plus 20 plus 20, again replica, 20 plus 20 plus 25. What is the width of the plate you should get? 130 millimeter. So this is your width of the plate, 130 millimeters. Next, diameter of the board 16 for 4.6 grade. For 4.6 grade, you note down FUB and FYB. FUB and FYB. It is 400 and 240 Newton per mm square. 400 and 240 Newton per mm square. Now, whether this lap joint is subjected to single shear or double shear. Your lap joint is, remember one thing, your lap joint is always subjected to single shear. So you have only one shear plane. You assume NN1, NS0. NN1, NS0. NN1, NS0. Is it clear? Next, you find ANB and ASB. Anyway, ASB is not required because when NS is 0, automatically this will become 0. Because of which here you don't require to calculate ASB, you directly calculate ANB. Okay, so your ANB is correct, 156, or you can round off this to 157. Okay, so you have all the data. Next is calculation. Shear capacity of bolt. Shear capacity of bolt. You know the formula VNSB equals FU divided by root 3 NN ANB plus NS ASB beta LJ. Three correction factors, beta LJ, beta LG, beta PK. Here the joint is lap joint. The given joint is lap joint. There is no question of packing plate. There is no question of packing plate. So you can directly take beta PK as 1. beta pk as 1. So you find the distances LG and LJ. What is LG here? Okay, grip length. What is the distance LG? It is 20 mm because this plate is 10 and this plate is also 10 mm. So 10 plus 10, 20 mm. Okay, so LG is 20. Next you find LJ from this board center to this distance. You find LG, sorry, LJ. Hmm. How much it is? See, what is this distance? I'm asking board from board center to center. I think it is clearly mentioned 40. Next, this is 40. 40 plus 40. So your LJ is 80 mm. Now, from my side, I have a good connection. Okay. So beta pk is 1. Next, same. You find the LJ 40 plus 40, 80 mm. You find the 15D. So 15 into diameter of the board 16, 240 mm. Now you compare this and this. So in this case, LJ is less than 15D because LJ is 80 and your 15D is 240. If this has satisfied, you can directly take beta LJ as 1. Beta LJ as 1. Is it clear? Okay. So you go for next correction factor. Next correction factor. You have the LG 10 plus 10 20 and you find the 5D 5 into bolt diameter 16, it is 80. You compare these two. So you compare LG and 5D. So your LG is 20, your 5D is 80. So LG is less than 5D because 20 is less than 80 mm. If this was the case, you can directly take beta LG as 1. Beta LG as 1. So you have three correction factor beta PK 1, beta LJ 1, beta LG 1. So correction factors 1. Is it clear? Next you substitute VNSB equals. Next you substitute VNSB. Okay. Now next you calculate VNSB. $36.25. So next VDSB. Next VDSB. 36 divided by 1.25. Is it correct? 29 kilonewton. Okay, the next, once the shear is over, next we calculate the bearing capacity of the bolt. Bearing capacity of the bolt. You first find KB. You first find KB answer. B first. Okay, 0.46 correct.
So
0.49 correct. 0.97. Last is 1. Your KB is smaller value. 0.46. It is correct. Correct for everyone. Okay, KB is 0.6. Next, VNPB. Next, you calculate VNPB. 75.44. Next, VDPB. 60.35. Bearing completer. Okay. Next. Next, you calculate bolt value. Next, you calculate the bolt value. Bolt value. Bolt value, or it is strength of bolt, or it is strength of bolt. It is very simple. You have shear, design shear, and you have design bearing. You have to compare and you take out the least value. So bolt value is 29 kilonewton for one bolt. Bolt value is 29 kilonewton for one bolt. For one bolt. Next, you find the strength of joint. Strength of joint with respect to bolts. In the diagram, how many bolts you have? 7 bolts. So 7 multiplied by 29, your strength of joint is 203. Strength of joint is 203. 203 correct, strength of joint. Don't get confused with the last problem. So in the last problem, here I multiplied by 7. 29 multiplied by 7. What is the answer? Again, you will get 203 kilonewton for shear. Okay. Next, 60 multiplied by 7. I think it is 420. Huh? So you are okay, 420. Huh? 420. So your strength of the joint again it will be minimum of the 203 only. Here I made multiplication factor at the end. So your strength of the joint is 203 kilonewton. Next, it is required to calculate the tensile strength of plate. In the next step, it is required to calculate the tensile strength of plate. So this is your arrangement. This is your lap joint arrangement. Okay. So this is triple staggered lap joint. So you have to calculate TDN. TDN for section 1, TDN for section 2, TDN for section 3. So this is section 1, section 2, section 3. Same diagram. Just I have marked the section lines. Section 1, section 2, section 3. Section 1 and 3, 2 bolts. Section 2, 3 bolts. First, section 1, 1. Section 1, 1. N and 2. Sorry, N number of bolts, 2. First, you need to calculate AN for this section, which means AN11. AN11, same formula. B minus NDH plus this is 0 multiplied by T. What is the width of the plate? Okay. You need diagram, huh? Yes. Same diagram, which I explained in the earlier. Just I have marked the 3 section lines. You first find the ANN1. Width of the plate is 130. Number of bolts here 2. DH 18 multiplied by thickness of the plate 10 mm. Is it 940? Okay. Next, TDN11, which means this is for section 11. So TDN11. Same formula 0.9 FU AN11 divided by gamma ml. So zero point 0.9 for plate FU is 410. Your AN value is 940 divided by 1.25 factor of safety. What is TDN11? What is TDN11? 277.48. Correct. So this is TDN11, 277.48 or 5. Next, section 22. Section 22. Here number of bolts 3. It will only change. Width of the plate, your bolt hole thickness remains the same. Your number of bolts n value it will change. AN 22760. TDN 224.35 plus 2 into 29 because here if this was the critical section, the number of bolts on this side 0. So while calculating TDN11, so 0 bolts. While calculating this section, so number of bolts at this side 2 bolts. So you have to multiply it by 2 into 29 for section 3. For section 3, for section 3, 5 into 29. 224 plus 2 into 29. 282 na. From this formula it is 224. For this you have to add 2 into 29. 2 number of, okay, 282 TDN22. So this is for section 22. Next is section 33. Section 33. Number of bolts 2. Number of bolts 2. Same, you will get same answer, 940. 940, correct? AN33. I think it is same as first. AN11 and AN33 are same, huh? Okay, because number of bolts are same. So it is 940. 940. Next. Hmm. See here, TDN33 equals 0.9 FU AN33 divided by gamma ml plus number of bolts on the left side of the section, 5 bolts, 5 into bolt value 29, 277 plus 77 plus 5 into 29. Four 22 na? 422. You have three answers. TDN11, TDN22, TDN33. Okay. TDN33. Next. Next. Next step is strength of joint. Next step is strength of joint. See here, you have strength of bolt 203. You have strength of plate at 3 sections. So section 1, section 2, section 3. So strength of bolt 203, TDN11 277, TDN22 282, TDN33 422. So out of these four, what is the least value? 203 kilonewton. So your strength of joint is 203 kilonewton. Your strength of the joint is 203 kilonewton. Next is efficiency. Same formula, strength of the joint divided by strength of solid plate. Strength of the joint divided by strength of solid plate. So strength of solid plate, same formula. First you find AG. So area of plate equals width into thickness. Your width of the plate is 130 and thickness of the plate 10. So it is 1300 mm square AG. You have the formula for strength of solid plate. For strength of solid plate, TDG equals 1300 multiplied by 250 divided by factor of safety 1.1. It is 295.45 kilonewton. Next you find the efficiency. Next you find the efficiency. Strength of joint divided by strength of solid plate multiplied by 100. So efficiency is 68%. So efficiency of the joint is 68%. Is it clear? So all the formulas are available in the code itself. So shear strength of bolt, bearing strength of bolt, plate strength, again at the end, strength of solid plate, all the formulas are available. Even correction factors also available in the code book. You have to remember the application, how to apply the values and how to substitute and simplify. Again at the examination, code book IS 800 2007 and steel table book so are permitted. So use of IS steel table and IS 800 2007 code are permitted. Wait, I'll take the attendance. Today, 8 members: Bhumika, Chetan, Niharika, Parvati, Shanmuka, Sujil, Tanushka.